PVCO has established an enviable reputation as a high-performance, durable pipe material which is ideal for pressure pipe and water supply applications. It is light and easy to handle, but tough and resistant to damage. To demonstrate this in a way that most contractors and asset owners can relate to, an installation contractor was asked to subject a length of 150mm diameter PN16 oriented PVCO pipe and PN35 ductile iron pipe to some extraordinary abuse. In the first instance, a section of pipe was placed in front of an excavator's tracks and driven over, not once, but twice. Although the pipe was severely creased and gouged by the excavator's tracks, it survived without penetration. The abuse did not end there, however. Everyone was keen to subject the pipe to extreme field installation conditions. An excavator was used to lift a rock weighing approximately 1/4 of a tonne to a height of 2.5 metres above a length of 150mm PVCO pipe. The rock was then allowed to free fall directly onto the PVCO pipe. An inspection of the pipe revealed it had sustained only minor surface markings from the impact and had become slightly out of round at the point of impact, demonstrating the amazing resistance to damage that PVCO has. The next step was to precisely repeat the rock drop test for comparison purposes using a length of PN35 ductile iron pipe. Given ductile iron's reputation for being a strong ductile material, it was assumed that it would suffer little visible damage, although the pipe's cement mortar lining was expected to crack internally and fall away. It was immediately apparent that the impact had seriously dented the surface of the ductile iron pipe. After brushing aside the dirt, a closer examination revealed a gash 100mm long by 10mm wide in the pipe. Although pipes would not be subjected to this type of abuse during installation, it clearly illustrates the toughness of PVCO compared to the ductile iron pipe. From here, the only remaining thing to do was to pressure test the PVCO pipe to determine the extent of any damage. Arrangements were made for the test pipe to be pressure tested to identify any splits, tears or weaknesses which were not apparent to the naked eye. The damaged section was cut from the test pipe and fitted with restrained end caps. The assembly was then connected to a hydrostatic test pump and fitted with a calibrated pressure gauge to register the point at which leakage or bursting might occur. The pipe was filled with water and pressure was applied whilst the PVCO pipe was monitored for leaks. As the handle was pumped, the pressure progressively increased, expanding the pipe and returning it closer to its original circular shape until the pressure reached 1600 kilopascals, the working pressure rating for this PVCO pipe. The pipe did not burst, and in fact, no leakage was detected during the test. One of the key benefits of biaxially oriented PVC pipe, more commonly known as PVCO, is the material's outstanding toughness and durability, which resists damage and provides decades of corrosion-free service life. Although this type of field testing is not likely to be included in the Australian standards or WASA pipeline codes, it clearly demonstrates the superior toughness, impact resistance and durability of PVCO pipes.